Hi there, back at it. I didn't think I was going to have time until a couple days from now. The timelines. Well, I guess at the end of the day, I'm just making excuses. But I found a couple minutes available that I can tinker. So I'm going to replace some capacitors that are easy to get to, should be relatively straightforward. That shouldn't take me, the hours it's been taking me to do these other things. So without further ado, let's see. I ordered the tabs from Amazon, and I'm going to put a little tab there. Put a tab here for these two capacitors, and then this rectifier that I got to replace with a diode. So while that's en route, let's get the glasses that allow me to see small things. I can see clearly now, my glasses are on. Well, if you tuned in for horrible singing, you're in the right place. How are they doing this? Well, they just had it going through the hole and soldered. It's kind of messy, but I already replaced this one a little while ago. That one's going through the hole and is sharing the shielding with the wire, so I gotta watch it with the heat. Speaking of heat, don't make sure you got no paper on top of your soldering iron. I don't want to move this. I don't know, these are like PCs or something like that. They're little square things with inductors, and they got parts in them. They're like old school ICs. So I don't want to move too much of that one, but I think I'm going to clip this capacitor out just so I can get better access to the solder. What'd you do with... you clipped that capacitor out of there. See that thing? Look at that thing. It didn't blow up yet. But I bet you if I tested it, probably leaks a little bit of DC or whatever. She's leaking. Not leaking. Leaking. Why am I telling you? You know more than I do about this thing. Alright. Clip. And we gotta remember the negative is to the ground. How's this capacitor looking? This is just a standard electrolytic. Huh. Looks pretty good. Sprague. Sprague. Don't be vague. Use Sprague. Anyways, 25, 25. Now, so 25, 25 is these little mamma jams. $25, $25. Alright. That's out of the way, but I don't want to move that PC thing too much. The fact that it goes across this terminal on the back of the switch is a little alarming, so I suppose I can... No, I can't. We're going to have to... there we go. That's right. Alright, and this little wire here goes to market. And this one goes to ground. Now, I do want to tell you what pin of the tube and which tube. That's a 6AU6 up there. But I do want to tell you what pin that is, but right now I want to get these capacitors replaced. So if you will bear with me until we get to checking voltages. Once we start checking voltages, gotta empty out the solder sucker. Once we start checking voltages in there, then we'll tell you what the new capacitors will do. I gotta read up on it anyway. I don't know. Did I tell you I don't know what I'm doing? What, did you wake up one day, kid, and say you're gonna do this shit? Yep, that's exactly what I was like 14. Now I'm going on 50. Still wearing jeans. Before that shielding gets in too much of it. So shielding goes back to this shielded wire, which is going to the, oh, that's an audio shielded wire. That's important, but that resistor with no shielding on it, just out there in the open, that's a little weird. I guess I better check that thing. But anyways, that is a audio shielding wire, and so I don't lose my place, I'm going to take my little capacitor, which is going to ground on that side, foil side, the side that does not say plus. I'm going to put it in there just so I can keep my place. But I also want to get this heat out. Come on, baby. Oh, don't overheat this thing. Come, get out of it. Get out of it. All right, not a good idea right now. It's not hot yet, but I don't want it getting hot. I'll remember it goes to the shield there. And now we got to do the old sucky. Me sucky short time. Well, it's sucky. I just pretty much suck at doing this stuff. I don't even know if I got anything with that. Where's smoke or fire, son? Put the fire in the wire. Down there on the Super Bowl. No. You know what? That do not disturb, it keeps the phone from doing its going off there, but it doesn't stop the any of the devices you have attached to your phone. That's okay. I don't mind the beeping anymore. I gotten used to that. It used to be like a trigger for me. Couldn't stand it. Is this thing loose in there? I got another flashlight. I think it's loose in there. Now, let me double check. I try to be careful putting extra heat in these things because, you know, there's a lot of components there. I had to do this lefty. How's everybody doing today? I see what they did. It's got the old captain here. The old Captain Hook. The captain! What have you done with the hook? I'm telling you, it's Captain Hook. There it is. Oh, yeah, like pulling the bullet out of a patient. No, not at all. No blood. No screaming. No trauma. Peaceful. Anyways, back to it. Back to life. Back to reality. Alright, so they hooked that one. We're going to hook this one. I'm going to trim it down a little bit with the ones that trim. Trim it down to about here. I, in like manner, will hook and if I could see clearly, yeah, see, you're getting the same songs over and over again. It's like a Clear Channel broadcast. Oh, hook, line, and sinker. I could even make that shorter, couldn't I? Let's look at this for a second. Do I want to make that shorter? I want to make it a little bit shorter. A wee bit shorter. Just be. The old captain on there, and we'll go sail. Come sail away. Lots of songs about fishing. I don't know any of them. I used to go fishing with my granddad over on Lake Columbia in Connecticut. We had a dock in the water, a beautiful thing. Anyways, back to this problem. All right, positives going to the positive. Why you gotta be so negative? It's raining. I'm sorry. I'm sorry. All right, so now we're just gonna grab Alright, that's had plenty of time to cool off. What we're going to do is put a little juicy on there. Good portion of that so that we can take this, put it on the, here are all my pliers falling on the ground, put it on there, and we can jab, jabby jab. We're hooking into everything though. It's like we're out for the bunker here. We're just getting anything we can. See if I can get that to poke through there. Get this to loosen up. Come on, baby. Come on. I don't want to get too hot. Some like it hot, but not this one. Ah, there it is. Woo-wee. Like blowing on it's going to help. Heat in there and push it the rest of it. One more heat in there and push the rest of it. Alright, there. Alright, let that cool down for a little bit while we hook it up. Alright. Oh, come on, go through. Oh, why aren't you captain? You were just hooked on there. And now you don't want to get the fit. Ah, that's why. Alright. That was a reflection, that is the hole. Let's kink it. And solder. Ah, I guess it wasn't kinked. thought I could see with these glasses. I don't know what happened to the hole. There, I can clearly see it. I just have a problem getting it. I'm gonna go back in. There it is. Ah, praises to God. Now we can get it. Woo-wee. All right. That resistor is still on there tight. And now it's soldered. Oh yeah, remember that noise? They were dropping on the floor. Alright, I don't know exactly how much time I got here to work on this thing, but I'm going to try to get it closer to done than I thought, because that power entry module took me a good 4 hours, 3 hours all said and done. I don't mind spending that kind of time on this thing, but I got 4,500 other projects around the house. Including and not limited to changing the oil on my Axolot's vehicle. This old stuff, sometimes you gotta get some extra solder on there for the flux, if anything. Who gives a flux? Alright. Done. It doesn't look unreasonable. Let's put this one back where we had it. Keep everything tight. Try to keep everything tight. Alright, and we're moving on. Nice. We're going to move on to this one. Looks like the same thing down here. It's jabbed through the terminal strip. Just coming off of that one. Now, we'll do this one, then we'll check the time. Because in here, maybe we should save that one for last. Because in here, I gotta also do, there's another one of those cans that I was talking about. Is that 3-in-1? So we got these three, which this is already going to a terminal tie strip up here, so that's good. That's already jumping down to ground as well as grounded, so that's good. This one over here is on a terminal tie strip, so that's good. It's just this little orange and white one down here which if I chase the line, orange and white goes here. And there's a terminal, nope, that's not ground. Well, there is a ground under here. Where's that going? Alright, that ground is coming from this rectifier. Can you hear me? This ground is coming from this rectifier. So this rectifier, selenium rectifier, has an input out of this choke or transformer here. And goes in for DC down to ground. And why does it do that? DC to ground. No, the double stacked one. Oh yeah. So it's got two rectifiers stacked on top of each other, in parallel with a resistor, in parallel with a capacitor. Now that's a big circuit. Where's the capacitor? Is that the one I'm looking at? Is that the one that's in parallel with what I'm seeing right now? Over this one line? This one line out of the transformer? Bang. That's the center tap out of the transformer. I should know what this thing's doing. I should know what this thing's doing. Hold on. Is that the grid reference from the plate on the modulator? Anyways, probably not. I'm stupid. Still trying to figure this out. So here's the rectifier. It's in parallel with this capacitor. Here, that's one of those 25 volters. And then the resistor is on the blue line here. Blue to this. That's not that blue. It's a different color. Blue. Now, there's going to be a resistor, I guess. Comes in and then it goes into this switch, which then feeds into the choke number 3. It feeds the grid for the 2E26. I'm supposed to know this. Which I'm guessing is, let's see, it's going to be that one. No. Anyways, we'll get there. I don't know what I'm saying. But we got one done. We're moving on. So let's, do we want to move on to those high voltage ones? Or do we want, let's get this one out of the way. This one, once it's gone, it'll be easier to do those other ones. So, positive, negative, that tag there, goodbye. Yeah. Where there's negative wire, there's that disc capacitor. I don't want to overheat that thing. Come in here and just get a little solder on there, come out. Smoke out of there. Again, we got to go left-handed. You know I was ambidextrous. Neither did I. Neither did I. Get that in there first. That way, when it's hot, I'll be ready with the button. I don't know if I got much. I'm in a rush. You see that? I almost tried handing. I don't get nothing. Nothing, honey. Let's wet it up a little bit more. Now I see it's wet. Ready and pow! That's a big chunk. That was a reasonable chunk. Keeping these things on your lap, and you shouldn't. You don't want to drop them. The capacitor should be able to handle a fall, but I don't want to mess them up. Is that loose yet? No. Alright, one more cycle. We're going to push it through. Yeah. See? Alright. After the 6AU6 is the it's a 12AX7. 12AX7, 6AL5, 6HU6. Right? Okay. So here's the 12AX7. And we're going to wet it. And then suck it. Wet it. I know every time I say suck it, Tony Hinchcliffe's getting a little excited, isn't he? How many people are fans of comedy? Myself, I truly enjoy comedy. In fact, part of what I'm doing is comedy. I don't know if you've listened to what I'm saying, but some of this stuff is hilarious. Try and spin this thing around so I can get the hook off. Captain Hook again. Shiver me timbers. I don't even know if that works. Alright. Next. 25 volt, 25 microfarad. 25 volt, 25 microfarad. Positive. You should be positive this is the right way to go. Well, maybe you want to sync the negative first. Maybe you want to put it in here and see how you're going to do this thing. There. Come about to here. 90. And then we're going to trim it out there. Going 90 degrees. Ain't that how we're supposed to square our actions? Again, to avoid overheating the capacitor, I'm going to get this wire ready to jam through there. Jab, jab, jab! And heat it up. And hopefully it doesn't stop. A little more right there. Perfect. Well, maybe a little more this time. Well, we hit it. Just a little more. Right there. You can hear the birdies singing now. Again, I usually have something on in the background. What I should have put on was the ham radio prep for the extra class, so I could stop being an idiot. Hook, line, and sink. Try to blow the smoke out of it. Smoke on the capacitor, fire in the wire. Kinky, stinky, and sticky. Don't want to get that ceramic disc too hot. All right, there's number 2. Put her in there nice, pretty like. She's done. If somebody thinks I'm making fun of them, I'm making fun of the Swedish chef. Now, here we are, my friends. So that's going to have to come back off of there. Oh, boy. Alright, I dig it. I'm going to have to move this PC line over to here, I think. Which I don't know if it's going to reach. And I'm going to be moving that thing around. Let me go check the time. So that thing's going to take me, once I get focused on it, I'm an hour into that thing. I'm just setting up that capacitor, and I don't want to take my focus off. Could do this one now. I know I got time to do this one. Let's go into that capacitor. Well, the amount of time I spent thinking about this thing. I gotta check that time. I got places to be. You know, if I was smart, I would have just looked at how long I've been recording. And like I said, I got a little bit of time to do this. So in a half an hour, I got 2 capacitors replaced. Made a plan, sort of. And I got 2 more. So I'm guessing I got about another hour before the capacitors are replaced. It's probably going to take me another 2 hours to test the voltages Oh heck, well, I got you here. I'll show you. In this book, which is the operating instructions. Now, back in the day, operating instructions actually told you something. So we got this table with these instructions. Up here. So, once I get the capacitors replaced, I will go through and have a notepad and I will record all the voltages and hope they're okay. Now, some of these where they're DC, I just replaced the capacitors and the diodes, so they should be clean, but I'm going to double check with the oscilloscope the ones that are low enough voltage. I don't have a high voltage probe, voltage divider, big brain stuff. I got a little brain. Someday. Let's see here. So yeah, anything that's like 150 volt DC, 200 volt DC, I can measure with the oscilloscope. I'm pretty sure, now that I say that, I'm thinking it might only go up to 50 on the DC line for measuring ripple. Anyways. So I'm going to measure voltages. I'm going to see what the voltages are. If the voltages are good, we're going to move forward. If the voltages are wonky, we got to figure out why. If it's a tube, I have a lot of tubes. I always take donations of tubes too. Again, donations are always welcome. My address, all that stuff. You find it on Google if you look hard enough. I'm not going to tell you here, because, well, yeah. Alright, so we're going to check these voltages at each one of these tubes, except for the AX9909. The tube is underneath, so we're going to have to chase the wire down to that 1000 volt transformer. It scares me. So, there we go. See a modulating swing of 180 milliamp peak. Compression switch in the on position measured with audio output meter. So I'm guessing you got to put a meter on the audio output. What is that star? Let's see. Let's find the star here. Man, we're here. Why not just look for it? AC, 75 volts AC on the 6AL5. Okay. Yeah. That's just to make sure that it doesn't keep it compressing. Function switch at CW position. Key contacts open. Switch attached to gain control in off position. See, that's a double tau. Negative 28 volt DC or positive 12 volts DC. So when you're conditions, and it tells you all this stuff right in the manual. If you know how to read. AC line voltage 115. Test meter 20,000 ohms per volt. We'll talk about that later. Function switch on the 40 meter band loaded to 320 milliamp. Grid current 12 milliamp. No modulation applied. Meter connected from specified point to chassis ground except where otherwise noted. What I'm doing right now also is I'm just kind of starting to digest this. I got a vacuum tube voltmeter upstairs. I'm not sure if it's this 20,000 ohms per volt. But I'll find out. Maybe I got to use that. Just starting to digest this a little bit. Maybe you want to too? Okay. Here, take a peek. You want to see the schematic too? Oh, you don't want that schematic. You want the update. There's two schematics here. This one's behind a film. There you go.
Try to get my face out of there so it focuses on.
All right. So there we go. That's it for today. I'm out of time. Oh, in a half an hour, I got 2 of them done, so I'm pretty happy about that. I'm not sure if I'm going to have any time to sink into this thing tomorrow, but if I do, we'll be happy to be back, and thank you for being here. Thank all of you for being here. Without you, I wouldn't be here. You know, I think there's one of you watching right now, so thanks, buddy. I appreciate it. Or budette. Thanks, friend. I appreciate you and every one of you. By the way, you can support the channel by shopping at Colin Stuff 2007 on eBay. You can donate directly to my front door, my mailbox. Yeah, any way you want. I appreciate you all. Thank you very much for being here, and we'll see you next time.